Part 3 of our Chapter 11 review. We'll do several of these questions. So I wrote them over here on the side, so we're going to look at 19. We're going to be using this triangle on the top right for 19. It is a right triangle with an altitude drawn from the right angle to the hypotenuse. So we had a few different theorems for this. We had that the altitude is the geometric mean between the two parts of the hypotenuse. And then we also had, we'll do this in orange, we had a leg is the geometric mean between the hypotenuse. And when we're talking about the hypotenuse, we're talking about the whole original hypotenuse and the part of the hypotenuse connected to the leg. So those are two of the theorems we can use. We also have right triangles, so we could use the Pythagorean theorem. Number 19, find WY. So WY, that's the altitude. Find WY if ZW equals 27. So this is 27, ZW, and WX is 3. So doesn't look like it would be 27 and 3, but those are the measurements we're given. Well, does this have to do with a leg or an altitude? Well, it has to do with an altitude. We want to find H. So for 19, we know the altitude is the geometric mean. So we're going to use this green formula here. So we put H here and here. And what are the two parts of the hypotenuse? Well, one is 27 and one is 3. We cross multiply. H squared equals 81. Take the square root of both sides, and we get H is equal to 9. So for number 19, we get H equal to 9. All right, we're going to erase those measurements for now. We're actually even going to erase this question, so we have room for the others. Again, hopefully you're doing this on another sheet of paper. Now, number 20 says find ZY. So ZY, that's this one. That's A. If ZW is 8 and ZX, the whole thing, is 10. Well, the question again is, does this have to do with an altitude or a leg? Well, this one has to do with a leg. We want to find the leg. And so for number 20, we're going to use the leg formula. So the leg, in this case A, is in those two spots. The hypotenuse is 10, and the part of the hypotenuse connected to the leg is this 8. So we cross multiply, we get A squared equals 80. You could put that in a calculator and get what that is. It's going to be probably like 8.9. But we can take the square root. When we take the square root, we can simplify this. This is the square of 16, which is a perfect square. That's why I'm choosing it. So we get 4 root 5. But again, you could put it in your calculator, and you'll probably get about 8.9. So that is number 20. Once again, erasing that information, we're going to go to the number 21. 21, find XY. XY, where is that? XY, that's this one. XY, which is a leg, if ZW, that's this one. ZW is 12. That's 12. And WX is 4. So are we looking for, or not even looking for, but are we dealing with an altitude or a leg? We're dealing with a leg. So we know, once again, we can use this orange formula, which has to do with the leg. So 21. The leg, which in this case is B, is the geometric mean between the hypotenuse. Well, be careful. What is the whole hypotenuse? It is 16, because we have a 12 and a 4. So 16. And then the part of the hypotenuse touching the leg that we're talking about, and that's 4. Cross multiply, b squared equals 64. Take the square root, and that is 8. So b equals 8. All right, let's erase that one, and we'll go to 22. 22. Find ZW. ZW. That's this one. We want to find ZW. If WX is 5, so this is 5, and ZY is 2 root 51. ZY. Yep. So, the question here is, are we dealing with an altitude or a leg? Well, this is dealing with a leg. It's right here. So, for 22, we're still using that leg formula. So the leg, which is 2 root 51, goes here and here, because it's the geometric mean between the hypotenuse, which is C plus 5. That's the whole thing, C plus 5. And part of the hypotenuse connected to the leg, which is just C. All right, so we need to cross multiply. So cross multiply, we have C times C plus 5 equals, now we multiply here, well, 2 root 51 times 2 root 51, you can do that in a calculator, but it's actually quicker not to. We got the 2 times 2 is 4. Square root of 51 times square root of 51 is just 51, because you would have square root of 51 squared. And so we have on the left c squared plus 5c equals, multiply those together, we get 205. I'll come down to this next area. This is a quadratic, so we would subtract 205 from both sides, and then we try to factor. How do we get c squared? Well, c times c equals c squared. And how do we get 205? Well, maybe we have 20 times 21. Nope, that wouldn't be right. Sorry. 205. So you might want to find the factors of 205. We know 4 times 51. So I think 12 and 17 also multiply to equal 205. So 12 and 17, which does work here, we would want to do a plus 17 and a minus 12. It doesn't work. 205 is not 12 times 17. That's 204. 205. Oh, well, that's the problem. 4 times 51 is 204, not 205. Sorry about that. So it is 17 and 12, which means c equals negative 17 or 12, but c is a length, so it can't be negative. So c is equal to 12. We got to use a quadratic equation in that one. Then it says we're going to jump to 24. 24 uses this triangle figure. Find BE. BE, that's this length. We'll call that X. If EC equals BD equals 6. So EC is 6, BD is 6, and DA equals 9. Well, we learned if things are partitioned like this, we can write 6 over 9 equals X over 6. We can cross multiply, nice and simple, 9x equals 36, and x divided by 9 has to equal 4. So x equals 4. There you have it. And then 27, it's the last one we'll do for this part. 27, we're using the figure over to the right. Find D. Can't just circle it and say D is right there. If A equals 2, B equals 5, and C equals 13. Definitely not drawn to scale, but we can have, just to make sure I did this right, A equals 2, B equals 5, and C equals 13. So we can say 2 over, what corresponds to 2? Well, 13. So 2 over 13 equals 5 over D. D, not 9. So we can cross multiply. We get 2D. 5 times 13 is 65, and divide both sides by 2. And we get D equals 32.5. Once again, definitely not drawn to scale. We can't go by how it looks, we go by the numbers. So 32.5, and we will finish that part